Hi everyone. Our topic in this module is the building envelope. In this video you're going to learn what that means and all of the different design considerations for a building envelope. And then in the next video we'll take a look at an important component of that envelope, and that's the windows. So let's start with a definition. The building envelope is the shell or enclosure around any internal conditioned space. So think of it like the envelope that holds your letters. The letter goes inside, the envelope goes around. All right. Any component that has conditioned space on one side and unconditioned space on the other is part of the building envelope. The building envelope will control the flow of heat. Heat will flow in and out of this envelope. Right? And so it's really important that you have an energy conserving building envelope. We're trying to exclude heat in the summer, keep it out, right? And to retain heat in the winter. How does our building gain or lose heat? There's three major sources of heat gain or loss through a building envelope. And if it's been a while since you've taken any physics classes, this may or may not be familiar to you. They are called conduction, convection, and radiation. Right? Conduction is the movement of heat through a material. Convection is the movement of heat through air movement, and radiation is a different form of heat radiated off of an object. Right? A building can also lose heat. All right, so those are three that go through the envelope. All right, but a building can also gain or lose heat through infiltration of air. This includes drafts and also the required ventilation for a home. And interestingly, a significant source of heat are the building occupants themselves. We humans, we put off some heat, right? And the equipment inside. Next, let's talk about the concept of thermal resistance. Materials will oppose the flow of heat through them. Right? And that amount of resistance is going to vary by the type of material. Some materials are better insulators, and some are better conductors of heat. So I'm pretty sure you already know this. Let's go ahead and imagine that this rod in this example is metal, and we hold it over a heat source like this flame. How fast is that heat going to flow towards your hand through that metal rod, through that physical material? All right, now that you have that in your mind, pretty fast, right? Imagine that this is a wood dowel, and assuming that it doesn't catch on fire, all right, assuming that we're holding it out of the flame, how fast is that heat going to flow towards your hand? When are you going to feel the heat? Much, much slower, right? So the wood is a better insulator than the metal, which is a better conductor. Right? They have different values of thermal resistance. As a designer, we're trying to control the flow of heat through our building envelope. Right? And we do this with thermal insulation. We're trying to prevent that heat loss or gain, and we're also trying to reduce the energy requirements of conditioning the air space inside. Right? So here we can see our thermal envelope, all right, our building envelope. It's this area right here, right, because we've got conditioned space inside and unconditioned space outside. This is part of the building envelope. In this attic, notice that this is not a conditioned attic, right? It's got ventilation through it. We've got insulation right here. So this piece right here is part of the building envelope because it's got conditioned space here and unconditioned space on this side, right? And so we're trying to control that heat flow through our building envelope. Here are some of the most common insulation types that we would go ahead and install in our buildings to control that heat flow. The most common, one that you're probably most familiar with, is a batt or a blanket insulation. It comes in two different types, a fiberglass bat and a mineral wool, or you might have heard it called a rock wool bat. Okay. Our next one is a loose fill material. This is blown into an area and it just lays there with gravity. All right, so it works great for attics like this where we're shown. We also have rigid board insulation, and there's multiple different materials of this. The rigid insulation is great for installing, let's see, on the underside of roofs, underside of your rafters, or on the outside of your wall, and it makes a smooth and continuous barrier of insulation. And our last kind here is spray foam. This is cavity insulation. It's going to go inside your wall, and it is sprayed into this area, and then it kind of expands a little bit and then firms or hardens into its final shape. Okay. So our topic today is a part of building science. And we know it's science because we can measure it. How do you measure heat flow? We measure it in R value, R for resistance. All right. And a higher R value has more thermal resistance. It's a better insulator against heat flow and heat movement. A lower R value is going to have less thermal resistance. And a material that has a lower R value will be a better conductor of heat. Let's take a look at where all of this insulation is installed in our building envelope. If you've been following along with our lecture videos so far, we've seen several different details, and I've placed them here and kind of colored in the insulation for you. So everywhere where there's bat insulation, I've colored it pink, and everywhere where there's rigid insulation, I've got blue. So starting over here, when we were looking at foundations, here is that basement foundation detail. We've got some bat insulation in the wall up here, and some rigid insulation along the exterior. Moving to our platform framing details. If you remember, we took a look at this masonry wall, and in this case they're really only showing bat insulation. We've got bat insulation here, and it would probably be in the attic as well, although it's not shown. Now here in California, with our Title 24 regulations and the increased amount of insulation required, you would probably, it's not shown in this detail, but you would probably need an additional layer of rigid insulation. Here's another example. I had you take a look at this wall section, right? And you can see that there is bat insulation in the wall and in the ceiling. And then there's rigid insulation along the exterior, right? In my opinion, it also needs it down here because this is unconditioned space. All right, so for this video, we're going to look at a different detail, all right, coming from Canada's Office of Energy Efficiency. And we're going to look at this detail here. So you can see that there is bat insulation in the wall, right, and in the ceiling, and then there's rigid insulation along the exterior. Let's zoom in on that, and looking at the bottom, we've got the foundation down here. We can see that we have uninterrupted insulation. So the insulation is going to run past these floor plates, right, uninterrupted and continuous. And then we have some right here. This is the wall. The rigid insulation runs continuous through here. Notice that they've added an extra piece, double thickness here at the floor plate because it's very easy for heat to kind of sneak around the corners of all of this different construction. And you want to make sure that there's no leaks of heat through your building. All right, moving on up, got our batt insulation, and you want to pay close attention to this detail here, because here is a possible leak of heat right through this corner, through this wood piece right here, and then it continues that way. Right? An important part of sealing your building envelope is also sealing it against drafts and air movement, right? Because that's another way that heat can kind of leak out of your building. And so we have an indication of an air barrier or a water resistant membrane. It's different in different locations on this drawing. It's kind of a dark dashed line. So starting from the bottom, this one's probably a water resistant membrane here. And then along the interior face, this is just the drywall. All right, the paper face of that drywall is taped and mudded, and it should be an air barrier. Right? We've got some water resistant membrane all along the exterior of the building. Right? And those need to be sealed at all of the joints. Right, so we see this little drop of sealant here. Thanks everyone. In this video, you just learned about the building envelope and the flow of heat through it.